Okay, so I think we can officially start. Welcome to our last webinar out of our DMAT webinar mini series titled The Future of Material Manufacturing, Embracing Open Source Digital Solutions for SME Growth. My name is Sally Stereva from the F6S team, and today I'm going to be hosting this session. Before delving into the topic of today, let me give you a brief overview of what is the DMAT mini-series and why we're doing this. Basically, we want to provide you with a very easily digestible overview of what are the opportunities and main barriers for adopting digital solutions within the material manufacturing field. Also, we want to explore further what are the benefits that actually open source digital solutions can bring to the fore. Since we are very considerable of your time, we have structured all our sessions in only 40 minutes time as duration, and we believe that in these short sessions, we can provide you with the added information and knowledge needed. What has happened up until now, as mentioned, this is our final session. We already had 3 pass. The first one was held on the 21st of November, and we started with digital trends and challenges across the material value chain. Then, in the following week, on the 5th of December, we focused on material data management, operationalization, and lifecycle assessment. Last week, we talked about predictive material behavior and advancing material design. And today, we're going to be speaking about digital simulation in material manufacturing. We're going to cover three main topics: numerical modeling for industrial SMEs, optimizing manufacturing process for SMEs through simulation. At the end, we're going to focus on enhancing process control for SMEs via digital twin solutions. In the last couple of minutes of today's session, I'm also going to be sharing with you the good news that we have already as well launched our call for early adopters, through which we're going to also open opportunities for different organizations such as yours to collaborate with the DMAT project. Now, let me move to the speakers of today. First, we have Javier Gomez, CEO of Advanced Material Simulation. Then with us, we have Jaume Sempere, Senior Technician in the Institute of Materials Technology of the Polytechnical University of Valencia. We have Konstantinos Tsitseklis, researcher at the National Technical University of Athens, and stated myself, and you already know me. About the agenda for today, I have already briefly shared with you during the overview, but we're going to start with Javier, who is going to be speaking about numerical modeling for industrial SMEs, overcoming the challenges in material property prediction. Then Jaume is going to focus on optimizing manufacturing processes for SMEs through simulation. And Konstantinos is going to speak about the digital twin technology. Something important that I have forgot to mention is that in case you have missed our previous 3 sessions, you can rewatch them on our YouTube channel. Everything is recorded and available there. Before we move to the main content of today, in case you have any questions, there is a chat box where you can post your questions. During the session, we're going to try to answer all your questions. And in case there is some time left at the end, we can also cover 1 or 2 additional queries. And this is it from myself. Now I'm giving the floor to Javier Gomez, who is going to speak about numerical modeling for industrial SMEs. Javi, the floor is yours.
Good afternoon. Thank you, Eli. Well, I will give you a short introduction about the first toolkit of this suite. And this toolkit deals with the prediction of mechanical properties of material and mechanical performance of component. Analyzing at the beginning which are the challenges that we have to affront in industrial material simulation, we can see that the current situation is very interesting from a scientific point of view and from an engineering, due to we can improve our manufacturing process, we can improve our product, introducing recent advance that we can have in material science, like new material, new manufacturing technologies like hydrogels, advanced composite, or other material, or additive manufacturing, or hybrid manufacturing. All these elements require a specific model. So dealing with engineering, we have the challenge to apply which is the optimum solution for our product. Mainly due to in the side of the modeling, not only due to the artificial intelligence, but mainly due to the appearance of new possibilities of our models. Nowadays, we can make physical model, or we can perform data-driven model, or physical model enhanced with artificial intelligence. We have the possibility of multi-scale and multi-physics simulation that are powerful. We are going to see some examples now. And everything is based in the advances in computational. From a decade, during the past decade, we have improved extremely our computational capabilities with new elements, with CPU, GPU, TPU, but also with new computational solutions. We can make some computation in cloud platform or cloud computing. That is a very new element for in our companies. In this complex world, it's necessary to sell it and the proper toolkit for our component and of our material. We have commercial solution that could be with some barriers at high cost and complexity. We want to combine different commercial solution or the commercial solution with open source. We have the lack of interoperability, and we are offering you the possibility to use our solution, to use our DMAT toolkit that is solving all the challenge. We are going to see now how our toolkit can help to you in your manufacturing process, in your manufacturing optimization design. Here we can see the advantages of our product. One of the first advantage, we are dealing with atomistic, we are dealing with finite element simulation, we are dealing with cutting-edge technologies. We are implementing in our toolkit multi-scale and multi-physics. I mean that we are living with atomistic, micro, meso, macro, and structural scale. We can predict the properties of material, but we can work with a structure, we can work with industrial components to analyze the mechanical performance, and we can analyze mechanical strength, damage, fracture, fatigue, and also combining with thermal behavior. As a first example of we can do with this toolkit, we can see in the next slide that with this type of toolkit, we can establish a link between the properties of our material, the properties of our component, and the composition and microstructure. To have this tool, to have the possibility of this link is very powerful due to we can optimize and we can reduce the trial error process. This toolkit, it could be in atomistic or with finite element solution. But go beyond this point, going a little bit beyond, we can mix our toolkit with artificial intelligence. And this mixture, this integration, give us a very powerful solution. It's very interesting to have a physical model with artificial intelligence. At the beginning, we are linking the composition, microstructure with the final properties, but with artificial intelligence, we amplify a lot this possibility. In the next slide, we can see a simple diagram of how to do this. We have data-driven model, we have physical model, and we have not only the composition with the strength. If we have enough data, we can establish a link between the important variables for our process, that is control variables. This is a very good example of how we are applying the artificial intelligence with physical model, and it's a very good opportunity to be with our call in early adopter to try to this type of scheme. In our second in our second idea that the mixture of artificial intelligence and physical model is very interesting is when we are dealing with real-time model. In the next slide, we can see an example of combination of very complex model, very complex workflow modeling. Our idea is to predict the behavior of a structural component, for example, a physics net, and to reach the final model, we have to combine to design the node to analyze the position of the equilibrium, tight the node, and make tensile simulation. During this process, we are making one particle simulation and two finite element simulation. And all this process with our technique, with the DIMAT technique, we can be included can be done in real time. We have a machine learning element that trained with physical model can perform all this process very quick. At the end of my part, I have included a link for a video, and it's possible to see how this has been achieved in DIMAT. Also, in the next slide, we can see other advantages of DIMAT toolkit. All our elements are open source. We are working with Calculus, we are working with OpenFOAM, with FreeCAD, with Blender, and it's robust solution. Due to this open source element are supported by the large research community. And all our toolkits are compatible with existing solution. The input and the output of our toolkit can be shared and can be opened easily with existing open source solution. So then it's very easy to implement and to incorporate in your design and your process all this DIMAT toolkit. Finally, I have included in the slide a link to in the next slide a QR code with a link to see more details of this toolkit. That's it. Thank you.
Thank you, Javi. Moving to the next speaker, it's Jaume Sempere, who is going to speak about optimizing manufacturing process for SMEs through simulation.
Thank you, Eli, for introduction. Okay. In today's competitive and resource-limited landscape, manufacturing faces critical changes, particularly for small and medium companies. But what if we could test new materials and optimize production without halting operations or consuming resources? Let's explore how digital solutions make this possible. In recent years, new technologies have emerged, enabling the application at various stages of industry with promising results. However, changes remain high production costs and inefficiencies. Many manufacturing processes still consume excessive resources, energy, limited resources for small and medium-sized enterprises that cannot afford to halt production lines for testing, leading to increased losses and reduced competitiveness. Then environmental impact, that inefficient process and resources consumption to contribute to environmental changes. The digitalization of industry introduced a new range of alternatives for industrial development, offering tools to optimize material manufacturing process and achieve a higher efficiency. Among the different digitalization techniques, simulation programs play a key role. Simulation programs that enable users to replicate real conditions by controlling process and help it identify the optimal condition and reduce production times, studying and analyzing the process, fostering a more productive industry while decreasing resources and energy consumption. Then resources efficiency and adjustments that simulation tools allow for testing new materials and product geometries without with the production lines and consumption raw materials and energy. This methodology can be empowering a small and medium enterprise with accessible and efficient tools to foster a sustainable and competitive industry aligned with European goals. Next slide. Thank you. Most of these tools offer extensive features, update material libraries, professional training, user-friendly, and advanced graphical interface, bringing the beginner user a safety environment. They are high-performance computational program capable of producing highly detailed simulation. Additionally, they provide technical support, provide companies maintain active high-cost license or annual subscriptions, sometimes paying for a version that faster becomes obsolete and with the impossibility to customize. The cost associated with these programs often deter companies from adopting digital tools, promoting them to turn to open access alternatives with high customization code. However, free simulation software has limitations, such as fewer data libraries or functionalities, requiring users to combine multiple programs. This presents challenges or barriers for many users with a steeper learning curve. This gap between paid and open access tools highlights the need to define a digital tools that remains accessible to small and medium-sized companies, often catering to specific modeling workflows. However, a free hardware capable of integration multi-library for modeling workflows manufacturing process has not been identified yet. This is where DMAT project seeks to introduce a suite of tools, including the material process simulation, designed to simulate materials transformation process. The DMPAs aims to identify optimal processing conditions and parameters by simulation, the requirements and conditions of a specific process and materials. For the successful development of the MPAs, a series of simulation must be conducted. Then the development of MPAs will be support of advances AI techniques present to provide modeling workflow and manufacturing process tools with the flexibility to be according to industrial needs. Going more deeper in the next slide. MPA's toolkit, and let's see what we need to define a simulation of manufacturing process. First, we need to identify the required data for replicated design process, like parameters, the key adjustable variables that control the internal behavior and performance of the simulation, boundaries, external conditions, and physical constraints that define the interaction between the system and its environment, and material properties are fundamental characteristics of the materials that influence in the behavior and the specific conditions. And let's see some examples in the next slide. In this case, the polymer extrusion process is a technique used for transforming plastics into products with a specific shape or developed blends of different materials. It begins with the feeding the material where it's transported inside a head barrel. In this case, the material will be adapted using the principal material properties such as density, the dynamic viscosity, one important property during the development of the simulation, and the thermal properties. During this process, the material melts due to a combination of head of friction. And for replicate the process, we should define the boundary conditions such as pressure, flow rate, and velocity. Then the material is then pushed through a die that will be defined for the geometry and the process temperature. The process is efficient and versatile and widely used in the industry of manufacturing a variety of plastic products. While applying digital tools to the process could be interesting to achieve new changes that brings plastic industry a decreasing material consumption. Otherwise, there are some challenges related to the different steps that explained today, like the need of an update material library, bringing the user an easy way to test new materials, recycling, and biopolymers, and some other challenges related with the faster and accuracy integration of real boundary conditions to simulate process to develop a more real replicate. And finally, automatization of the parameters to test faster challenges without having the need to interface with the production line. And in the last slide, These challenges in material process simulation are connected with the demand targets, the development of three suites that will provide user of accessibility of simulation tools, providing an scalable, cost-effective solution tailored for small and medium enterprise niche, avoiding a high cost and technical barriers, always searching for an optimization of manufacturing process using the interoperability between the toolkits, such as the possibility to connect with a cool material database of Suite 1 to update material data, or the material designer of Suite 2 to optimize the material data or the needs. This will provide the user to the opportunity to an accuracy in simulation process. For the development of these objectives, also we will use a cutting-edge technologies and real-time possibility with the integration of digital twin technology of Suite 3 that my partner Kostas will be explained later on. And that is all from my side. Thank you for your attention.
Thank you, Jaume, as well for the presentation. And now indeed we're moving to Kostas, who is going to speak about process control for SMEs with digital twin technology.
Yes, thank you, Eli. Hello all. So in my today's talk, we're going to talk a little bit about why employing digital twin technology can actually help SMEs in this era. So to begin with, we need to define what is a digital twin. Well, we can think of a digital twin as the virtual counterpart of a physical system. For DIMAT scope, this can either be a manufacturing device, a material that is used in the manufacturing process, or any other monitoring equipment. You can think of devices such as sensors, other IoT devices, data loggers, etc. What the digital twin actually does is that it copies the physical attributes and the operations of the physical counterpart. In order to do so, it connects with a real object in real time. This is essential in order to have a working digital twin. The digital twin also provides simulations and emulations, and also can provide predictions based on historical data that has been saved in the system. Moreover, it can control the equipment according to best practices that are either specified by the experts or that they are inferred through analysis of data. So moving on to the next slide. Well, why digital twins are necessary today? Well, first of all, manufacturing processes are quite complex. Employing digital twin technology can help in monitoring in a single instance, allowing easier inspection of the whole manufacturing process. Also, the digital twin can help in the timely maintenance of devices. Access to predictions and to simulations can reduce downtime because scenarios can be first assessed in the digital world and thus reduce cost that would arise from failed experiment. So, reduced downtime equals more profit for the business and also less cost because failed experiments have been avoided. Okay, so if the digital twins are so beneficial, why are they not adopted by all the SMEs? Well, just a couple of barriers that SMEs pose, that are faced by SMEs. First of all, there's the lack of awareness about this specific technology, and also many SMEs have inexperienced personnel for this technology. This means that they may have very skillful engineers or other personnel, but lack the specific IT personnel to handle the digital twin. Moreover, there are many closed source software platforms for deploying digital twins, but these are quite pricey, and this might be an obstacle for a small medium enterprise. Of course, there are also data privacy concerns, meaning the owners are very concerned about who handles their data, where their data is stored, and fear any potential data leakage. And also, of course, there's the uncertainty in terms of the return of the investment, meaning that okay, the business may be willing to invest in this technology, but they expect their profits to grow in return, and they're not sure if they can accomplish this with this technology. Moving forward to what we propose in the scope of DIMAT, which is the development of the digital twin for process control toolkit, in short, DTPC. Well, DTPC is an open source software that it's based on the Nepheli VO software stack, which is a software stack based on the Web of Things standard. The DTPC supports secure connection with the real equipment over popular protocols like HTTP, MQTT, or others, and can provide enough security mechanisms in order to ensure the safe transmission of data between the business site and where the digital twin is hosted. The DTPC can be connected with the other two toolkits of the suite, MMS and MPS, that my colleagues explained earlier on, and it can provide out-of-the-box functionalities for any type of industry. These functionalities are real-time monitoring and alerts, time series-based predictions. We have created also dashboards that allow for easy visual inspection of the metrics that are captured by the twin. And of course, this technology can support more detailed processes, and we can develop more detailed software tailor-made for each partner or customer of DTPC. Now we can take a look at some of the more basic functionalities of the toolkit that are supported for any kind of industry. First of all, an important aspect is forecasting. We support 4 different popular algorithms for forecasting. These algorithms are either classic time series-based algorithms like ARIMA models and auto-ARIMA models, Prophet, which is an open source algorithm created by Meta, and for a more machine learning approach, we have the LSTM models. For each one of these, we provide some default values for the parameters, but this, of course, can be changed by the users in order to have something more specific for their own use case if they know how to do so. Selecting the method and setting the parameters or using the default ones, you can get a figure that looks like the one you can see in the right-hand part of the screen with the actual values and the forecasted ones for the near future. This is a very useful capability of the toolkit, since forecasting may be required in order for the personnel to be able to make some decisions about the manufacturing process. Moving on to the next slide. We have monitoring. We offer a front-end page that can display what is currently measured by the twin. All the time series related metrics can be displayed in this page. We have color coded the values that are within range to be in blue color. Any metrics that are captured and indicated as out of range will be colored in red. And so we provide an easy way to detect faults in devices or to detect any faulty equipment, meaning maybe a sensor has been damaged or something like that. And to the next slide. Okay, we also provide a page that handles management of the limits of each time series metric. So the user can select for each time series metric the appropriate ranges, setting lower and upper limits. And this is something that contributes to the alert mechanism in order to be notified whenever there are measurements that fall outside of this range, and this might indicate a problem in production. And now, these are the basic out-of-the-box functionalities. Let's talk a little bit about a more specific one that we also have in DIMAT we are working on with a partner. So, Ellie, if you can play the video. Yeah. Here, what we have, it's a module that can infer the temperature distribution inside a furnace. We get some metrics for some sensors, and we infer the temperature in all the points of a plane inside the furnace, a plane that we choose, and we see this plot that is updated in real time. And what actually does, it plots the temperature across this specific plane, and we can evaluate easily which plane displays a homogeneous temperature distribution versus planes that maybe have more variance in the temperature. So this is all for the digital twin capabilities. If you would like to learn something more in more detail, you can either read either read our publication Digital Twin Meets Knowledge Graph for Intelligent Manufacturing Processes, in which we provide further details and we explain how the digital twin can also be connected with another DIMAT toolkit, the knowledge acquisition framework, in order to support a specific use case. Or you can also check a demo video of a preliminary version of the toolkit that goes a little bit in more detail about the user interface and the functionalities that I described earlier on. So with this, I would like to thank you very much for your attention. Thank you.
Thank you, Kostas. Okay, and now that we heard all about our solutions, not only now in this session, but the previous three as well. And as I said, in case you have missed them, you can always go to our YouTube channel and watch them. We actually want to invite you to collaborate with us through the call for early adopters that we are launching today. As you understood, the solutions that we are developing are already well advanced. And not only that, but we are testing them with different pilots within different materials, such as polymers, for example, graphite, glass, and so forth. And now we want to extend to external organizations as well who can become part of our DMAT project. How this can happen is if you apply through our call for early adopters, which is open from today for a duration of up to 2 months. And basically through this call, we want to understand what are your needs. We want you to get access to the solutions that we are developing for us to fine tune them and to understand what is the product market fit. Not only that, but we want to bring different types of contributions for your digitalization needs. What we're going to do is, apart from identifying the solutions that are mostly relevant for you, you're going to have an assigned mentor who is going to support you in interacting with the solutions, but also on identifying key aspects of enhancing your overall digital strategy for your different operational and business processes. Additionally, we're as well going to position you as an innovative collaborator with the DMAT project through different spotlight articles and communication opportunities via our social media channels. And furthermore, you are going to get preferential access to the DMAT solutions once they're finally developed as at the end of the DMAT project. In order to do that, basically you have to follow 2 simple steps. All the information related to the DMAT call for early adopters is available on our website, the DMAT website. We have a tab called Community. When you click on it, you're going to get access to the information, and there is a guidelines for applicants, a short document that you can read in order to understand whether the call for early adopters is for you and what you can gain out of it. And after you have got acquainted with the definitions and the guidelines for applicants, you go and apply through the F6S platform. You see on this page the link. You click on the link, and in case you have not created yet a profile on the F6S profile, you need to create such, which is in your added benefits, since this is the largest platform for founders worldwide, where you can get access not only to different funding opportunities available internationally, but also access to different industrial partners, to events for collaboration and so forth, to acceleration services and so forth. After you create your profile, you have different opportunities to do that. You see the 4 different options here on my screen. After the profile is created, you are just going to get a direct access to the application. The application is very straightforward. Everything is available on the platform. You do not need to submit any additional documents. You answer to the questions identified here. Basically, we just want to understand what is your profile, whether you're suitable and interested in the solutions, in which solutions out of the ones that we have discussed in our webinars, but also they're carefully described also in our guidelines for applicants, in which solutions you're interested in order for us to understand how we can support you the best. And this is basically it. You can apply by the end of February. Afterwards, we're going to have a short evaluation period. And then we're going to be selecting up to 5 organizations that will collaborate with us for a duration of up to 2 months for March and April. For the organizations that were not selected, it is not because we don't want to work with a lot of organizations, it's just the resources that we want to focus and concentrate in order to adequately support you the best. But for the rest of the organizations, you will have access to the discussion board on the F6S page, where we're going to share relevant information regarding the topic of concern, which is open source digital solutions for material manufacturing. And also we're going to provide you with information of additional events, webinar sessions, opinion and research articles that are coming out. And in case you have any questions, of course, focus only on the topic. We are going to engage with our experts. You have seen that within the DMAT consortium, you have excellent expertise coming from different types of research and private entities, universities as well. So we have the capacity to provide you with the needed information as per your requests. And this is basically it. The call is officially launched today at 5 o'clock CET. So once this is done, you can go ahead, go to the application page and apply. I think this was everything on my side. Thank you for that. I saw that there is a hand raised, but afterwards I did not see any question in the Q&A chat box. In case you have any questions and you cannot provide them now, as I said, you can directly contact us. You have both my email and my colleague Sarah's email. We are the ones interacting with you for the event. You can contact us further and let us know. We will try to answer as soon as possible. Thank you for tuning in. This was our last session from our 4-part mini series. Next year, we're going to continue with a lot more interesting, additionally, and equally interesting topics related to open digital solutions in material manufacturing. Thank you and have a lovely rest of the day. Bye.